intersection of two curves here. So that such type of curves are called as hyperbola. When we intersect a plane between those two napped right circular cones, we'll get a curve, and that curve is called as the conic section. The distance from the fixed point to the any point on the circle is called as the radius of the circle. When we have -2, 3, here the value of h is -2 and k is 3. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am, Department of Mathematics. Today in this session, we are going to study about the conic section. So in that, we'll study about more on circle. So what do you mean by conic section? So conic sections or a conic is an intersection of a curve with respect to the double inverted cones here. So when we have two cones on one another, nap it together. So when we intersect a plane between those two napped right circular cones, we'll get a curve, and that curve is called as the conic section. So when we insert a plane with respect to these cones, we will get basically four types of curves. In that, the first one is the circle, second is the parabola, the third is the ellipse, and the fourth one is the hyperbola. So let us see how we are going to get all these four types of conic section. So you can clearly see I have mentioned an angle alpha and beta here. Basically, with respect to alpha and beta, we are classified the rest four types of the conic sections. So we have circle, ellipse, parabola and hyperbola. So when the plane cuts the nape of the cone, so you can see from the figure, in any direction, when a plane cuts the nape of the cone, we have the following situation. So based on the situations, we have four types of curves, that is conic sections. Since they are all part of the cone, they are called as conic section. So if when beta is equal to 90 degree, the section is a circle. So you can see the diagram here. When a plane intersects the cone exactly at 90 degree. So here you can see the beta, which is exactly 90 degree. If it is 90 degree, then the intersection of the cone and the plane termed to be a circle. Next we have when alpha is less than beta and less than 90 degree. That means when both are acute angle. So alpha is less than beta is obviously acute angle because beta is less than 90 degree. When both are acute angle, then the section is an ellipse. So you can see from the figure here, alpha value as well as beta value is less than 90 degree. So you can see this is less than 90 degree. When you measure it in a anti-clockwise direction, and when such cases arrived, you can see we can create a curve called ellipse. Next we have the intersection in such a way that beta is equal to alpha. That is when the alpha and beta angle are equal to each other. You can see the curve here it creates. So when it cuts, the plane cuts exactly the nape of the cone. So it creates a shape like this, which is called as parabola. Next we have 0 less than or equal to beta, beta less than alpha. So 0 means beta can be anything, whereas alpha is greater than beta, then the section is hyperbola. So here you can clearly see when it intersects in such a way that it cuts two cones in such a way that it creates two curves here. So this is a curve. So you can see a curve in this form. When it intersects in this way, so it creates a two curves, intersection of two curves here. So that such type of curves are called as hyperbola. So depending on these situation, when a plane makes an intersection with the cone, then the curve created will be the circle, ellipse, parabola or hyperbola. So we will study the properties and the characteristics of these conic sections one by one. In that, in today's session, we will be studying about the circles. So we already know that a circle is a set of points that are equidistant from a fixed point, where that fixed point is called as the center of the circle, and the distance from the fixed point to the any point on the circle is called as the radius of the circle. So studying about the properties of the circle, we have a general equation of a circle which is in the form of x minus h whole square plus y minus k whole square is equal to r square. Here h comma k, so h and k represents the center of the circle and R represents the radius. Suppose H and K is origin in such a way that suppose you have a circle whose center is origin. Then the equation of the circle will be of the form x square plus y square is equal to r square. So this is the general equation of the circle whose center is the 0, 0. Now suppose we have a circle whose center is along the x-axis. If this is the center, we know that any point on x-axis will have y coordinate as 0. So the center can be written in the form of h, 0. Then the equation of the circle will be of the form x minus h whole square plus y square is equal to r square. That is, if the center lies on x-axis. Now in such a case, suppose if the center of the circle lies on the y-axis, any point on the y-axis have x coordinate 0. So therefore the center becomes 0, k here. Hence the equation of the circle will be x square plus y minus k whole square is equal to r square. So these are the special cases of the general equation of the circle when they lie on the center with center 0, 0 and the center lie on the x-axis and center lie along y-axis. Otherwise, in any other cases, it can be written as x minus h whole square plus y minus k whole square is equal to r square, where h, k represents the radius, where h, k represents the coordinates of the center and r represents the radius of the given circle. Now let us take the problems based on the equations of the circle. Find an equation of the circle with center minus 2, 3 and radius 4. So when we have minus 2, 3, here the value of h is minus 2 and k is 3. We know the general equation is x minus h whole square plus y minus k whole square is equal to r square. So substituting this, we'll get x plus 2 whole square plus y plus 3 whole square is equal to 4 square. So this will be the general equation. Here 4 square is 16. We can also simplify this and convert all the terms to any one of the side. If you expand this, we will get x square plus 4 plus 4x plus y square plus 9 plus 6y is equal to 16. Or we can write this as x square plus y square plus 4x plus 6y. So 9 plus 4 will be 13. 30 minus 16 is minus 3 is equal to 0. So this is the another form of expressing the equation of the circle. So in general, we have one more form of a circle, that is x square plus y square plus 2gx plus 2fy plus c is equal to 0. So here 2g, 2f and c will have different values. You can see here in the place of 2g it is 4, in the place of 2f it is 6, in the place of c it is minus 3. So this is also one of the standard equation of the circle. So which when expanded from this form, you will get reduced to this form. That is x square plus y square plus 2gx plus 2fy plus c is equal to 0. Next, find an equation of the circle with center 1, 1 and radius root 2. So then the equation becomes x minus 1 whole square plus y minus 1 whole square is equal to 2. Because r square is root 2 whole square, which becomes 2. So if the question is asked only in the form of 1 mark question or in the form of an MCQ directly, this is the answer. It can also be asked in the expanded form. Just you need to expand this using the identities, which becomes x square plus 1 minus 2x plus y square plus 1 minus 2y is equal to 2. So you can see here x square plus y square minus 2x minus 2y. 1 plus 1 cancels, 2 cancels is equal to 0. So this is the expanded form of the given circle. Find the center and radius of the circle x square plus y square plus 8x plus 10y minus 8 is equal to 0. So this is given in the expanded form. We need to reduce it in the form of x minus h whole square plus y minus k whole square is equal to 0. Then find h, k as well as the radius. So we have the equation. So let us write the x variables first. We have x square plus 8x and then the y variables. We have y square plus 10y. We'll shift the constant to the right hand side, which becomes 8. Now we have these two terms separately. So use the concept of completing the square method. So here what I'll do, x square plus 8x. So use the concept of a square plus 2ab. Now I need to add b square here. So whatever you are adding b square, to make it as a perfect square, you are adding it on the both side. Now if I consider this in the form of 2ab, assume a is x. So 2a is 4, we need to add 4 square. So add 4 square on both sides here. 8 plus 4 square. Next here we have y square plus 2 5s are 10y. So here what I'll do, I'll add 5 square on both sides. Now this is in the form of a square plus 2ab plus b square, which can be written as x plus 4 whole square. And here y plus 5 whole square is equal to 8 plus 16. So 16 plus 8 will be 24. 24 plus 25 will be 49. Now to reduce this into standard form, the standard form is in the form of x minus h. But here I have plus. So I'll separate this as x minus 4 whole square plus y minus 5 whole square is equal to 7 square, because 49 is a square of 7. So therefore now h comma k takes the values of minus 4 comma minus 5, and the radius of the circle will be equal to 7. Next one. Find the center and radius of the circle x plus 5 whole square y minus 3 whole square is equal to 36. So it's the direct substitution. We can write this in the form of x minus 5 whole square. This is as it is. And here this can be written as 6 square. So therefore h comma k is minus 5 comma 3 and r is equal to 6. So next question we have, find the equation of the circle which passes through the points 2 comma minus 2 and 3 comma 4 and whose center lies on the line x plus y is equal to 2. Now here the general equation of the circle is given by x minus h whole square plus y minus k whole square is equal to r square. Since this equation is passing through 2 comma minus 2 and 3 comma 4, we can substitute the value of x and y as a solution here. So taking x and y as 2 comma minus 2, we'll get this as 2 minus h whole square minus 2 minus k whole square is equal to r square. Let this be taken as 1. And similarly, we'll get 3 minus h whole square plus 4 minus k whole square is equal to r square. Let this be equation 2. Again, since the center h comma k is on the line x plus y is equal to 2, h comma k can be taken as the solution for the given line. So let us take this h plus k is equal to 2 as equation 3. Now from this here, we can take k as 2 minus h. So now compare these two. We have 2 minus h whole square minus 2 minus k whole square is equal to 3 minus h whole square plus 4 minus k whole square. Now in the place of k, we can use 2 minus h. So here 2 minus h can be written as k square. Next we have minus 2 minus 2 minus h, which becomes 2 plus h whole square, because k is 2 minus h, so minus 2 plus h. Next we have 3 minus h whole square plus 4 minus k. So 4 minus k can be written as 4 minus k is 2 minus h again, which becomes minus 2 plus h whole square. So here 2 minus h can also be replaced back in the form of 2 minus h, because we have every quantity in the form of an h here. So here also we'll keep 2 minus h whole square. Now when we expand this, we get 4 plus h square minus 4h. So next we have minus 2 minus 2. So which becomes minus 4 plus h whole square or h minus 4 whole square, which can be written as h square plus 16 minus 8h. Next we have 9 plus h square minus 6h. Next we have 2 plus h whole square, that is 4 plus h square plus 4h. So we can cancel h square, h square. Next we can cancel 4, 4. We can also add this. So minus 4h minus 8h is minus 12h plus 16. Next here we have minus 6h plus 4h as minus 2h plus 9. So solving this we'll get minus 10h plus 7 is equal to 0, or h is equal to 7 by 10. So if I substitute h is equal to 7 by 10 here, then this becomes 2 minus 7 by 10. So which will be 20 minus 7, that is 13 by 10. So therefore h takes the value of 7 by 10 and k takes the value of 13 by 10. So therefore the general equation can be written in the form of x minus 7 by 10 whole square plus y minus 13 by 10 whole square is equal to r square. Now to find the value of r, we can substitute the value of h and value of k in any one of the equation. Then the general equation of the circle can be written in the form of x minus 7 by 10 whole square. We can also reduce this in the decimal form. Y minus 13 by 10 whole square is equal to 12.58 after expanding. So that is the required equation of the circle. Next, find the equation of the circle passing through the points 4, 1 and 6, 5 and whose center lie on the line 4x plus y is equal to 16. We can also use the equation of the line to confront the other two equations, or we can also use the method of simultaneous linear equation. So since the circle is passing through 4, 1, the equation of the circle can be used as 4 minus h whole square plus 1 minus k whole square is equal to r square. And the other equation is 6 minus h whole square plus 5 minus k whole square is equal to r square. Now the center lies on the line 4x plus y is equal to 16. So therefore, I can write this as 4h plus k is equal to 16. So let this be equation 3, 1 and 2. So equation 1 and 2 we have 4 minus h whole square 1 minus k whole square is equal to 6 minus h whole square plus 5 minus k whole square. We can expand and solve here. So we will get 16 plus h square minus 8h plus 1 plus k square minus 2k. Next we have 36 plus h square minus 12h. Next we have 5 minus k, which is 25 plus k square minus 10k. So we can cancel h square and k square on both sides. So next we are left with minus 8h. So when 12h shift towards this side, it becomes 12h minus 8h, which becomes 4h. So next we have minus 2k and here we have minus 10k. So 10k minus 2k is 8k. So next we have here two constants, 16 plus 1, which becomes 17. So I can take here it as plus 17, 36 plus 25. So minus 61 is equal to 0. So we can write this as 4h plus 8k minus 44, which becomes 44. So let me take this as equation 4. So clearly from equation 3 and equation 4, so instead of 4h, I can rewrite this 4h as 16 minus k. So substituting here 16 minus k plus 8k is equal to 44. So we will get 7k is equal to 28 or k is equal to 4. So here using the simultaneous linear equation method, now when you substitute k is equal to 4 here, we are left with 4h is equal to 16 minus 4, which is 12. So that implies h is equal to 3. Now we got h is equal to 3 and k is equal to 4. Substitute in any one of the equation. Let me consider equation 1 here. So taking h is equal to 3, 4 minus 3 is 1 square 1. Next, taking k is equal to 4 here, 1 minus 4 is minus 3 whole square is 9, whose value is r square. So this implies r is equal to root 10, r square is equal to 10. Now since the general equation is in terms of r square, so therefore the equation of the circle can be written as x minus 3 whole square plus y minus k whole square is equal to r square, which is 10. So this is the required equation of the circle. Next, find the equation of the circle with center 2, 2 and passes through the point 4, 5. So we have a circle whose center is 2, 2 and it is passing through some point 4, 5. Now center is already known. Let's find the radius. We can apply the distance formula to find r here. So r is equal to 5 minus 2 whole square plus 4 minus 2 whole square, or we can take it as r square without square root. So 5 minus 2 whole square is 3 square 9 plus 2 square 4, which is equal to 13. So therefore the equation can be written in the form of x minus 2 whole square plus y minus 2 whole square is equal to r square, whose value is 13. The center is 2, 2 and hence the general equation is x minus 2 whole square plus y minus 2 whole square is equal to 13. The next one is find the equation of the circle with radius 5 whose center lies on x-axis and passing through the point 2, 3. So radius is given. The center is also given, that is it lies on the x-axis. Any point on the x-axis means the center will be of the form h, 0. And some point is given on the circle. Radius is given 5. So I already told you an equation of the circle whose center lie on the x-axis will be of the form x minus h whole square plus y square is equal to r square. R square is here 5 square, which is 25. Now my aim is to find the value of h. So again let us use the distance formula here. So which can be written as 5 square is equal to 3 minus 0 whole square, which becomes 3 square plus 2 minus h whole square. Now we have 25 minus 9 is equal to 2 minus h whole square. So this implies 2 minus h whole square is equal to 16, or 2 minus h is equal to plus or minus 4. Because we are talking about the center, which means the coordinate, it may lie on the positive side of x-axis or on the negative side of the x-axis. So therefore the square root should be taken in both form, plus and minus. So now if I take 2 minus h is equal to 4, then h will be minus 2. Then the general equation becomes x plus 2 whole square plus y square is equal to 25. If I take 2 minus h as minus 4, then h will be equal to 6. Then the general equation will be x minus 6 whole square plus y square is equal to 25. So depending upon the h, the general equation may change with respect to h is equal to minus 2 and h is equal to 6. The next thing is we are checking whether the point is inside or outside or on the circle. If any point is inside the circle, you can clearly see this is the radius of the circle and this is the distance CP. So I have taken a point P here whose distance is less than the radius. So if the distance of a point from the center of a circle is less than the radius, it means the point is inside the circle. If you take a point, let me take a point Q here. So the distance from the center is same as the radius. If the distance and the radius are equal, then the point is on the circle. It lies on the circle. I am taking a point outside the circle, so it obviously means it is greater than the radius. So if the distance of a point from the center of a circle is greater than the radius, we can clearly say the point is outside the circle. Again, how to calculate distance EP? Using the distance formula. So today we have learnt about the first part of the conic section, the circle. I'll meet you in the next session with the new concept. Until then, keep watching, keep learning and keep exploring. Thank you.